Have you ever wondered how to master stateful apps with StatefulSet in Kubernetes? Well, you've come to the right place. Today, we're going to uncover the mysteries of Kubernetes and the StatefulSet controller. Kubernetes, or K8s for short, is an open-source platform that automates deploying, scaling, and managing containerized applications. It groups containers that make up an application into logical units for easy management and discovery. Kubernetes is about making the complex task of managing thousands of containers feel like managing just a handful. But what's a container, you might ask? Imagine it as a lightweight, standalone, executable package that includes everything needed to run a piece of software. This includes the code, a runtime, libraries, environment variables, and config files. Now let's talk about StatefulSet, which is one of the workhorse controllers in Kubernetes. It's a bit different from its siblings, like deployment and replica set. StatefulSet is specifically designed for applications that require stable network identities, stable persistent storage, and ordered, graceful deployment and scaling. Why is that important? Well, not all applications are the same. Some, like web servers or front-end apps, are stateless, meaning they don't need to remember anything from one session to another. But others, like databases or streaming platforms, are stateful. They need to remember things. They need to maintain their state between sessions. And that's where StatefulSet comes in. In the Kubernetes world, managing stateful applications can be a bit of a challenge. They require more care and feeding than their stateless counterparts. But with the help of StatefulSet, we can ensure that our stateful applications run smoothly, reliably, and predictably. So, we've scratched the surface of Kubernetes and StatefulSet. We've learned that Kubernetes is about managing containers and StatefulSet is about managing stateful applications within that environment. But we're just getting started. In the next segment, we will dive deeper into the process of setting up a StatefulSet. So, stay tuned, and let's continue this journey together. Now that we understand what a StatefulSet is, let's explore how to set one up. Setting up a StatefulSet in Kubernetes involves three main steps: creating a headless service, defining a StatefulSet configuration, and applying the configuration using the kubectl apply command. First, you need to create a headless service. A headless service is a type of service that doesn't have a cluster IP and is used to manage network identity for the pods. You can create one by writing a YAML configuration file, specifying none for the cluster IP. This file should include the service name, labels, and the app protocol. Once done, apply it using the kubectl apply command. Next, we define the StatefulSet configuration. This configuration, also written in YML, outlines the specifications of the StatefulSet, including the number of replicas, the pod template, and the volume claim template. The pod template details the container specifications, such as the image to use and the ports to expose. The volume claim template, on the other hand, specifies the persistent volume for each replica in the StatefulSet. It's important to note that each replica will have its own unique network identity and its own persistent storage, thanks to the headless service and the volume claim template respectively. Finally, we apply the StatefulSet configuration using the kubectl apply command. This command creates the StatefulSet and the specified number of replicas along with their respective persistent volumes. If you want to check the status of the StatefulSet, you can use the kubectl get StatefulSets command. And there you have it. You've just set up a StatefulSet in Kubernetes. Remember, the power of a StatefulSet lies in its ability to manage the deployment and scaling of a set of pods, and providing guarantees about the ordering and uniqueness of these pods. It's a crucial tool when dealing with stateful applications. Once the StatefulSet is set up, it's time to understand how to manage it effectively. A StatefulSet is only as good as its management. So, how do you manage a StatefulSet effectively? Let's dive right in. One of the key practices for managing a StatefulSet in Kubernetes is performing rolling updates. This means gradually updating pods in a StatefulSet, rather than doing it all at once. This practice allows your application to continue running and serving its users even while updates are being made. To perform a rolling update, you would use the rolling update strategy, which updates each pod in the reverse order of their ordinal index, minimizing disruption. Next, let's talk about scaling. Scaling is adjusting the number of replicas in a StatefulSet. either increasing or decreasing them based on the load requirements. This is done using the scale subcommand in Kubernetes. The beauty of scaling in Kubernetes is that it can be done automatically, so your applications can respond to user demand in real time. Deletion is another essential aspect of managing a stateful set. When you delete a stateful set in Kubernetes, it doesn't automatically delete the pods in that set. This is to prevent accidental data loss. If you want to delete a stateful set and its pods, you have to do it explicitly using the cascade option. Now, managing a stateful set isn't just about performing updates, scaling, and deletion. It's also about monitoring and maintaining the stateful set to ensure optimal performance. You should regularly check the status of your pods, monitor resource usage, and keep an eye out for any errors or issues. Kubernetes provides various tools for this, like the kubectl describe command and the Kubernetes dashboard. In summary, managing a stateful set effectively involves performing rolling updates, scaling based on demand, careful deletion, and regular monitoring and maintenance. Remember, the goal is to ensure that your stateful applications run smoothly and reliably, no matter what. Now that we know how to manage a stateful set, let's talk about the common challenges faced and how to overcome them. Like any technology, stateful set comes with its own set of challenges. But don't worry, we've got solutions for them. First up, maintaining data consistency. StatefulSet works beautifully with stateful applications, but ensuring data consistency across multiple replicas can be a bit of a pickle. The solution? Kubernetes provides a feature called volume claim templates to maintain a consistent set of persistent volumes. This ensures that each pod in the stateful set has its own unique, consistent data. Next, let's tackle the challenge of handling network partitions. In a distributed system like Kubernetes, network partitions can occur, causing a disruption in the communication between pods. This can lead to data inconsistency and other issues. The remedy here is to use a combination of readiness probes and liveness probes. These probes check the health of your pods, ensuring they're ready to accept traffic and functioning correctly. This mitigates the risks associated with network partitions. Then we have the task of managing resource limits. Without proper management, your applications can either starve for resources or hog them all, neither of which is ideal. The antidote? Kubernetes gives you the ability to set resource requests and limits for your pods. This helps you ensure that your applications have the resources they need without monopolizing the entire cluster. It's also crucial to remember that understanding these challenges is only half the battle. Implementing these solutions requires a good grasp of Kubernetes and the StatefulSet concept. Keep practicing, keep learning, and don't be afraid to ask for help when you need it. Remember, Kubernetes and StatefulSet are powerful tools, but they're just that, tools. They're only as effective as the person wielding them. So, invest time in understanding them, in overcoming their challenges, and in learning how to make them work for you. Understanding these challenges and their solutions brings us one step closer to mastering StatefulSet. Let's recap what we've learned today about mastering stateful apps with StatefulSet in Kubernetes. We kicked off our journey by introducing Kubernetes and StatefulSet. We learned that Kubernetes is a powerful tool for managing containerized applications, and StatefulSet is a Kubernetes workload API object, designed specifically for applications that require stable network identifiers, stable persistent storage, and orderly deployment and scaling. Moving on, we delved into setting up a stateful set. We discovered that the first step is to define the stateful set in a YAML file. This file holds the blueprint of the stateful set, specifying the number of replicas, the template for the pods, and the volume claim templates for persistent storage. We also discussed how to apply this YAML file using the kubectl apply command. Next, we ventured into managing a stateful set. We explored how to scale up or down the stateful set, update the stateful set configuration, and delete the stateful set. We also looked at how Kubernetes automatically handles the recovery of failed pods in a stateful set. Then, we faced the challenges that come with StatefulSet and found solutions. We discussed how StatefulSet pods are not easy to horizontally scale due to their stateful nature. But we also learned that we can overcome this challenge by carefully designing our application and using persistent volumes that support read-write-many access mode. In conclusion, we've seen that mastering StatefulSet is crucial for managing stateful applications in Kubernetes. It offers unique features like stable network identifiers, stable persistent storage, and orderly deployment and scaling, which are not available in other Kubernetes objects. This makes it an excellent choice for applications that need to maintain state or data consistency over time and across network disruptions. Remember, mastering StatefulSet is a journey, not a destination. Keep learning, keep experimenting, and you'll be a StatefulSet pro in no time.